Okay, today we're going to graph systems of inequalities. So yesterday we spent a lot of time graphing just one inequality. Today we're going to graph two and more. So here you have your first problem. You have got a system of inequalities. I'm going to graph each line individually, and then the goal is to figure out where the shadings overlap. So the first inequality, I'm going to have a b-value at -3 and a slope of 2. All right, so I'm going to draw a dotted line here because of my inequality. And if y is less than this, then we're going to shade below the line. All right, second inequality here. I'm going to solve this for y really quick. Y is more than 2 minus 2x. So my b value is at +2 and my slope is -2. So I'm going to rise 2, I guess, and go to the left one. And I can go in the other direction too. Okay, so I'm going to have this being, again, a dotted line. And my inequality symbol is y is greater than, so I'm going to be shading above the line. Now your job is to indicate where these where these shadings overlap. So what you'll want to do with your pencils, you'll just want to make the part where they overlap darker so that I can see where the solutions are. If you want to check your work, what you can do is you can just take a point in this shaded area. So like I could use the point, it looks like 5, 1 is definitely in that shaded area. I could use that point and just plug it back into both of the inequalities and make sure that they are true. So if I plug it back into the first one, I'm going to get 1 is less than 2 times 5 minus 3. Into the second one, 2 times 1 plus 5 is more than 1. And these are both true. You could also take these and plug them into your calculator and check that way. Let's look at each of these. Same type of problem. I'm going to start with my b value at 5 on the first one, 1, 2, 3, 4, 5. And my slope is -1. All right, so I'm going to have a solid line this time because of my inequality. And I'm going to be shading above because y is greater than. All right, let's look at my second inequality. I'm going to just really quick, easily I can solve for y. So y is less than or equal to -4 plus 3x. So I'm going to have, let's see, a b value -4, 1, 2, 3, 4. And my slope is 3, so rise 3, run, run. All right. Again, solid line. And in this one, you're going to be shading below the line because y is less than. And so you're going to want to indicate to me the solution area, which is right here. And again, you could check algebraically, you could check with your calculator, either way. Okay, let's go the other direction now. Let's look at a graph of a system of inequalities, and let's try to figure out what those equations would be to create this graph. So what I need you to know is that you can't really see this on your paper, but this area right here in green is the solution area. That's important. You'll need that. So just know that. Let's first start by finding the equation of the red line. First of all, I notice that my red line is dotted, so I'm going to need to be using either a greater than symbol or a less than symbol. So you should be thinking about the solution area. This line must be shaded below the boundary line because my solution area was below the boundary line. So that should indicate to you that the symbol should be less than. That's going to get your shading below the line. But we still need to figure out what the slope is of this red line and then what the b value is. So let's count up. Let's figure out the b value. 2, 3, 4, 5. Your b value is a +5. Now let's take the time to figure out the slope. Again, this is from a few chapters ago. I would just pick 2 points that you can easily see on the graph and just calculate the slope. So it looks like they ran 4 in this direction and rose 2. So your slope would be 2 over 4. And actually note that the slope of the line is negative, so it's going to be negative 2 over 4, which is negative 1/2. So you're going to have negative 1/2 x. So that's the equation of the red line. Now you have to find the equation of the blue. So again, you know you're going to have y. And think about the shading. If the solution area is up here, then that means that you would have to be shading above the blue line, which means y would have to be greater than. And notice that the blue line is solid, so you can put an equal sign under there. Let's figure out what our b value is. Negative 1. And then really quick, our slope. Looks like we can just use these 2 points. And they ran 1 and rose 1, so the slope is just positive 1x. All right, there you go. And you can check that again in your calculator, make sure that you're doing that right. Okay, these are tough problems. These are word problems with systems of inequality. So I need you to try to pay as close attention as you can. Come to class tomorrow with questions. All right, so you're planning what to do after school. You can spend at most 6 hours daily playing basketball and doing homework combined. So you only have 6 hours after school to do these 2 things. Several things need to be true. You want to spend less than 2 hours playing basketball, and you must spend at least 1.5 hours on homework. You need to show a graph explaining this whole scenario. So let's first start with defining our variables. I'm going to let x be the number of hours playing basketball. I'm going to let y be the number of hours doing homework. Now, you can spend at most 6 hours doing both of these activities. So it's fair to say that x plus 6, the total time you spend on both activities, must be less than or equal to 6. Also, let's read this sentence here. You want to spend less than 2 hours playing basketball. If x is the number of hours playing basketball, then x needs to be less than 2. And then the next sentence says you must spend at least 1.5 hours on homework. Hey, Veronica, you can just, I've got them out there for you. So you must spend at least 1.5 hours on homework, which means if y is the number of hours doing homework, then y must be more than or equal to 1.5. Okay, so here's the tricky part. You've got to graph each of these, and your job is to figure out where they overlap. So I'm going to graph my first one here, which is just, I'm going to change this here to y is less than 6 minus x. So you have a b value of 6. 1, 2, 3, 4, 5, 6. All right. And you've got a negative slope here. Okay. Now let me ask you something else about this picture here. If the x-axis represents the number of hours playing b-ball, and y represents the number of hours doing homework, does it make sense to have negative x values or negative y values? Does it make sense to have anything over here or down here? It actually doesn't, because it doesn't make sense to have negative numbers of hours. So I'm just going to limit myself to this first quadrant. That's going to help you get a nice picture. Okay, so I've sketched my graph. Now I need to sketch the shading here. For my red line, I know y is less than 6 minus x, so it's going to be everything less than that, which is that area right there. My second inequality here is x is less than 2. So I'm going to come here to x equals 2, and I'm going to draw a dotted line. And I know if x is less than that, then it's got to be shaded everything to the left. Okay, so you're kind of seeing where they overlap. My last inequality is y is more than or equal to 1.5. So I'm going to draw a line here at 1.5. And y should be everything more than that, which you can see really clearly now what the solution area is. I'm just going to draw it in black here. Okay. So the goal is to break this down into inequalities and graph each one separately, figure out their solution by figuring out where their shading overlaps. Okay, let's look at the next one really quick. Here this says cherries cost $4 a pound and grapes cost $2.50 a pound. You can spend no more than $15 on fruit, and you need at least 4 pounds in all. What is the graph showing the amount of fruit each that you can buy? Yeah. Okay, let me just finish this really quick and I can do that. Okay, what I'm going to do is I'm going to let X represent the number of pounds of cherries, and I'm going to let Y represent the number of pounds of grapes. And I know I can only spend $15, so I'm going to write my first inequality here. 4x plus 250y. This total cost here has to be less than or equal to 15. I can spend at most $15. The second constraint is that you need at least 4 pounds in all. So all your cherries and all your grapes combined, you need 4 pounds. So x plus y must be at least, so must be more than or equal to 4. So there's no other constraints if you read through. There's nothing else you need to worry about. So what you need to do is graph each of these. Okay, I'm going to stop here. You guys graph this on your own, see how you do. We'll go over this tomorrow together.